So welcome back. Let's continue our lecture series on drug metabolism and talk about phase 1 and phase 2 reactions. So what we're going to do here is break this up into two parts. And so phase 1 metabolism, I just want you right now to associate it with the cytochrome P450 system. And that's something we alluded to on the last lecture. And so what enzymes is is phase 1 metabolism using? What class of enzymes? And so the class of enzymes we use are called oxidases. And what do these oxidases do? Well, they unmask or introduce polar groups. Examples being O's and OH's, hence the term oxidases. And they unmask these polar groups on the drug. And what we're going to do in about 1 minute is actually draw out this reaction so you can see it and understand it. And the name of these oxidases, by and large, the largest family of drugs working in the phase 1 metabolism are the cytochrome P450. And so we see CYP, that's where it comes from, and then 450. Now, where does the 450 come from? This is confused lots of people. Well, these are heme-containing enzymes. And just a little historical tidbit, remember that heme binds oxygen, but more than oxygen, heme binds carbon monoxide. And so when heme binds and forms carbon monoxide, the maximum wavelength that it absorbs is 450 nanometers, and that's where the name comes from. But let's look at phase 1 metabolism here. And the reason we're going to do this is so that you get it, so that you understand. So we start with a drug, and what we want to do now is take this drug, metabolize it, and form a more water-soluble drug. And so I'm just going to write a drug with a star, and that star means it's more water-soluble. Well, the first thing, let's switch colors here. The first thing I want to realize is we're using oxidases. We're trying to introduce or unmask polar groups. And so cytochrome P450, because we are heme-containing enzymes, we know they like to deal with oxygen. So I'm just going to write in oxygen here. And so one thing that does happen is we have this O2. One of these oxygens ends up binding to this drug. The other oxygen ends up forming H2O. So let's just put in O here, and I'll write the H2, and I'm being a little anal about color coding, but whatever. H2. So where are we getting the hydrogens from? Well, the hydrogens we are getting from NADPH. NADPH. And hopefully you remember NADPH. This is from biochemistry. So NADPH, we covered, well, not we, but you probably covered sometime in the past. This was part of the pentose phosphate shunt, or pathway, whatever you want to call it. Do you remember when we took, glucose 6-phosphate, and we formed 6-phosphogluconate? Oh, good old biochemistry. Well, as a byproduct, we formed an NADPH. Important concept. And so NADPH actually acts as a reducing agent. It's a reducing agent. So what do I mean when I say reducing agent? Who knew biochemistry was going to come back? By reducing agent, it means it can reduce other molecules. And so we remember oil rig, oxygen is loss of an electron, reduction is gain, oil rig. By being a reducing agent, it causes other molecules to get reduced, to gain an electron. And as a result, it loses an electron. So we would expect, if it is a reducing agent, if it's losing an electron, it itself is getting oxidized. And by losing an electron, at the end here we form NADP+, positively charged. The big picture here, though, is that we are using cytochrome P450. We have a requirement for molecular oxygen. One of those oxygens goes and binds to the drug. The other oxygen goes and typically forms water. And the enzyme we are using here is cytochrome P450. And that is phase 1 metabolism. Now you can get much more detailed with it, but that's the big picture I think you should know. But there are other non-cytochrome P450 enzymes that are in phase 1 reactions, but they constitute the minority. But one of them I do think you should know is alcohol dehydrogenase, right? This breaks down alcohol, and it takes alcohol, we use alcohol dehydrogenase, and it forms acetaldehyde, which is actually one of the side effect producing components of alcohol. And acetaldehyde is later broken down into acetate. We'll cover that later. Now, the cytochrome P450 family has a unique way of being named. And so we'll see these names 3A4 or 2D6. What do those mean? So these are probably two of the most common cytochrome P450 enzymes. And so the way this naming works is 3 represents the family of drugs. The A represents the subfamily of enzyme. And the 4 represents the actual isozyme, the individual isozyme. I think of this as a family. This is the, grandmother, this is the mother, and this is the daughter. And it's the individual person right here. So the iso 1 zyme 1 enzyme. And this is phase 1 metabolism.